All right, we're live. So last time we implemented loop and recur, which
Didn't we do precedence?
oh, we did precedence. Yes, I'm sorry. We did loop and recur the time before. So yeah, we got the precedence, so that's good. Now we don't have to write all these parentheses. And today what we're going to do is actually two assignments. The first one being recognizing a top level function, which in this case can only be main. And the second assignment being just passing arguments into the main function from the command line, which will enable us to do programs that actually output something different depending on what the input is, or actually giving the program input, right? Which so far we couldn't do. So far, all our programs would always output the same number. So this shouldn't be too difficult. We just need to, well, first we need to define a data structure for this. I'm going to call this let's just call it a function. Abstract function t. And so what does a function have? A function has a name, then it has a number of parameters, and then it has a body. So we're just going to do this the way we always do it. We have a name, and then we have an int, an args. Then we have the names of the arguments. And then we have the body. And now we might want to add a function to evaluate a function. Eval function, environment t, and of course it needs a function. Well, so we don't need an environment because the function doesn't have an environment, right? Only the body inside the function, when you evaluate it, has an environment, but that environment comes from the arguments that are passed in. But what it does have is it has arguments. And we can actually write this function right away. Namely, in the interpreter. And I'm actually going to steal some code. Should I steal? Do I have to steal? Does that make sense? No, I don't think that makes any sense. So what do I need to do now to run the function, to evaluate the function with these arguments? I need to call eval_expr, obviously, on the body. I'm sorry, on the body being the expression, but I need an environment. And the environment needs to contain the arguments to the function bound to the names of the arguments to the function, right? So I will make an environment T env equals null. And then I'm going to say, I'm just going to iterate over the arguments. And what do I do? I bind the function. Yeah, just call it args. Yeah, that's fine. Args of I to args of I. And now I have the environment. And I can call, well, eval expr with the environment and the function body. But now I also need to free, if I want to do it right, I need to free the environment. Where do I have all of that environment stuff defined? Is that in the interpreter? Env lookup, env bind, env free. While env is not env old. So basically, if I do env free with the environment and then I say null, that should free the whole environment, right? Return result. So that's nice. Now what I actually need to do is to parse the function.
Should you take in like a bunch of expressions as args instead of like the N64? Or are you gonna evaluate the args in a different function?
No, so we are going to use this function in two places. The first one right now, when you call the interpreter on the command line, you can pass in numbers as arguments, right? You cannot pass in simplank expressions here,
Right.
right? You can't say 1 + 1 for 2. Yeah. But we could do that, in which case we would have to parse them as expressions. That would actually be kind of nice. But anyway, that's not what we're doing. We're not doing that. And can I just turn that off? Okay, awesome. Thank you. So what we get is just a bunch of numbers. And the second place where we use eval function, which will come later, is when we actually call functions from within other functions. Right here, when we process function calls. And in that case, the caller has to evaluate the arguments in the caller's environment, and then we call eval function with the already evaluated arguments, basically numbers again. Because this guy doesn't know which environment to evaluate the arguments in, right? This should not be this function's concern. Okay, so coming back, we're going to extend the parser. But actually what we're going to do is, first of all, we're going to function t parse function inside a context. Now we can write the parser. So let's look again at our grammar. Where is it? There it is. So what do? We expect a let token context token let when we get a, let's expect returns the token, right? Yes. And the token T equals expect token context token identifier. So this is the name of the function. I'm going to actually allocate equals, we have this alloc expr. So I need pool alloc, pull from the context size of function T. Now I can put the name in t.v.name. We got the name, and now we have the parameters. So what we do is we need, so parameters, there has to be at least one parameter. So we know we have to parse, we know we expect at least one identifier. And we're running this while, how does it look ahead? While lookahead.type equals token ident. So as long as we're parsing identifiers, we're consuming them. However, we need to save them, obviously, somewhere. So we're going to make a RTR .r init .r append. So we're just going to append the names of the arguments. And then we're going to put in function n_args equals $r length. And the arguments is a char pointer array $r data of r, and at this point r becomes invalid. Then we have an equal and an assignment operator. So expect token assign, and now we parse the expression. Function body equals parse expr. What do I give it? Just the context? Yep, just the context. And then I expect token end, and I return the function, and that's it. Now, to verify that this actually does produce something, I should, what's our init? Parse main, scan main, eval main. I should call it parse function main. And it's going to parse a function t function, parse function, and it's going to print the function. And that is always top level, so we don't need an indentation. Here we're going to write void function. And what was the output format? So I'm printing parentf function, then with two indents. How do I do this? Print indent, yeah, okay. Print indent with two indents. I print the name of the function. And then for int I equals 0 less than function and args, I print one more ident, not indent, ident. No, indent. 3 function args of I. And then I print the body with one indent. Am I missing anything, or is this all there is?
I think that's it.
Looks good so far.
Why does expect token take the context in again?
Because it might have to, well, first of all, the scanner is in the context, right? Well, no, actually, the file and the look ahead and the pool from which it needs to allocate identifiers in case there are identifiers. So let's make a test case for this one here. So this is 11 tests parser 1.11. Really? There was no 9. Yeah. Yeah. No 10. Yeah.
There's a 10.
Yeah, there is a 10, but it was the precedence. So there was no parsing associated with it. Oh. Wait, what? If the last thing was that we did was precedence. Oh no, this is a parser thing. I should rename that. Interpreter 1.10 to parser 1.10. Okay. So parser 1.11. Yeah, let's try this one. Parser 1.11 ads.sl. And now let's run on tests parser 1.11. And that looks pretty good, right? Function main AB plus AB. Pretty happy with that.
Yeah.
That's that out. All right. That is really pretty much all there is. I could try parsing. Well, no, I can't parse bigger functions, but in the examples there should be more complicated ones, maybe shiftal. No, yeah, I always write them as two functions. But so if I feed in this, then it should print the shiftal function, right? Which it does. Because it only parses one function and then it stops. So yeah, I'm actually going to commit that first. Properly name test here for assignment 1.10. That, and then we have this thing, this thing, this thing, and this thing. Assignment 12. 11. 11, right?
Yeah.
Ooh, okay, that was easy. So the only thing now that we're missing is for assignment 12 is that when we're calling our little program with the when we're calling the interpreter from the command line, we need to be able to parse these arguments and pass them to the interpreter. And am I going to be lazy again? Yeah, I think, well, no, I can't be that lazy. Oh, no, I don't have to be because I know how many arguments there are. So,
From argc, you mean?
Yeah. The problem was I thought I would need a dynamic array again, but I don't because I know in advance how many arguments there are, right?
Yeah,
because it's in argc. The only problem is that, yeah, this is what I'm going to do. I'm going to say eval function main and argc minus 2 argv plus 2. And here I'm going to say if it's less than 2 args. Because the stupid thing is that some of these, I should write a proper command line parser where you can say, oh, just scan, or but I'm lazy. So whatever, this is a hack. Don't do it this way. I just don't want to write C argument parsing code. Eval function main with argc argv. Now what I'm going to do is actually, no, this is what I'm going to do. I'm going to parse a function. Now I'm going to, first of all, the name of the function should be main. if it's not main, then I'm going to say printf error function must be main. Do I exit or do I return? I'm going to exit. Exit 1. And then if function n args is a different number than argc, error function main expects the args but got function n args argc. And now I can key args equals malloc. I mean, I could, yeah, why would I allocate it in the pool? Yeah, why not? Syntax pool argc times size of 64. Now I have my args. And now all I need to do is spur to L. Spur to LL. Spur to IMAX. Yeah, I'm just going to do straight to LL. Quad. What is a quad T? I don't even know what that is. I've never seen that type name before. Anyway, stdlib. Where are we? Args of I equals in 64T strut tall argv of I end pointer is null, base is 10. In 64T result equals eval function. No, I cannot call that eval function. Yes. Eval function args. And then that.
The result.
No, I'm doing it here. Boom. Is that gonna work? Taking bets.
I'm not ready for it.
You don't think it's gonna work?
I'm hopeful, but also realistic.
I think it'll work.
Do we have an add? Yes, we have an add. So examples add 1, 2. Huzzah!
Oh, jeez.
So why didn't you guys tell me? Missing a new line.
Oh man.
And of course, if I do it on Shiftle, it will say that the function cannot be main, right? Because it's
Yeah.
Yeah. That's it. Not much to it.
Do you want to return a different error code? So we
For
can
what?
like instead of return 1, return 2 the second time?
Well, sure.
Yes. Okay.
If you write the man page where it says what the error codes are. Okay. So yeah, that was really very easy. We didn't add much functionality other than being able to pass arguments in. But we can now actually, well, no, we can't test that. I'm too lazy. I'm gonna have to figure out how to do this, how to do the test thing, because my test suite. No, it does. It does. Wait. In the tests, I have the full thing. Oh, that's how it works. So the way it works is that if there is a file called .tests, then these are pairs of inputs and outputs. So for example, in Shiftle, right? Shift 0 by 0 is 0. Shift 1, 2, 3 by 10 gives you this number. So these are the inputs to the program and the arguments, basically, and this is the expected output. And the program itself is expected to be in examples with the same name, which is stupid, but whatever. Does that make sense? So basically, I could, because we have the add thing, I could make a interpreter 1.12 thing and write in there add.tests, and it would say 1, 2, 3.
Mm-hmm.
And then if I run test here with interpreter 1.12 and the thing, then it's going to say, yeah, 1, 2, 3, 1 test, 0 failures. Actually, I wonder how many of these examples it set. Yeah, I always did this thing where the main function calls the other one. So this is actually fun because it's division. If you don't have division.
Oh yeah. Mm-hmm.
It's basically my own implementation of division, but whatever. We can't run this yet. Euler fib leading zeros less probably. Yeah, I'll just copy the less. Also copy tests full less into tests interpreter 1.12, and then I'm going to run it again. Okay, that works too. All right, so for the next one, I guess for the next one, well, the second one is pretty easy if you do the parser bit, right? So what we're adding here is the ability to define more than one function. So the things that have changed in the grammar are this part, where it's not one function, but it's one or more. the function itself is the same as before. But now also we have this rule, which I should maybe mark the lines that are changed in the document. We have this rule which says that pretty much using the same syntax as recur, we can now also call a function identified by an identifier. And that's a function call. And in assignment 114, you'll have to extend the interpreter to actually make those function calls do something. And doing something means calling the functions and returning the results. But this part is really, really easy if you have this part. And this part is not difficult because you already have the code to parse an individual function. You already have the code to parse a recur. And parsing a function call is the same, except that it's an identifier. Well, there's one slight difference. So there is the case where an identifier might mean a variable, or it might mean the name of a function to call, right?
Mm-hmm.
So for example, in, I don't know, here, we have leading zeros. There could be a variable named leading zeros. I mean, there isn't in this case, but the parser doesn't know that because the parser isn't keeping tabs on which variables are defined. But the thing is that the argument must always start with an open parenthesis. And there must be at least one argument. And the only way you can have an identifier followed by an open parenthesis is in this case. So to distinguish between this one, between the variable reference and the function call, you just check, is it followed by a parenthesis?
Okay.
Does that make sense?
Yeah, that makes sense.
So I should maybe, first of all, I should write that into the document. But also should commit this and the test. Oh, of course, I forgot the tests. Assignment 111. Parser 111. I'm gonna amend. And then this and these tests. And what I'm going to do is I'm just going to define the data structures that we're going to have. Because I don't care about speed, what I'm going to do is I'm just going to linearly link the functions together. Function T, what the hell? Oh, struct function T. Right, so I'm just going to build a list of all the functions that I have. And then whenever we call a function, I'm just going to search through the list because I'm lazy. And then we need, let's call it expr call. And I'm just going to rename this to recur and call because they use exactly the same data and they parse pretty much in exactly the same way. And that's all the data structure changes that need to happen. Any questions?
Not yet.
Okay. So that's it for next time then. Guess we're done. Cheers.
Thank you. Cheers.